Thank you. The aim of this study is to present an analysis of historical satellite tag data from North Atlantic right whales, specifically looking at movement behavior. I'm Daniel Palacios, and my co-authors are Ladd Irvine, Ryan Schosberg, Mark Baumgartner, and Bruce Mate. Between 1989 and 2000, Oregon State University deployed 35 Argos tags in the Bay of Fundy. Two types of tags were used. 19 were anchored type of tags, and 16 were consolidated. The maps shown here depict the locations of the 35 tag deployments with colored circles indicating tags that transmitted 3 or more locations. Tag design evolved from early anchored types where the electronics package remained external to fully implantable consolidated tags, designs that reduce drag and remain the standard today. So those are the ones on your right. Several excellent studies have been published with the tag data. Mate et al. Provided a descriptive characterization of movements and habitat use based on the 1989 to 1991 deployments. Baumgartner and Mate extended the analysis to the 2000 deployments and conducted a quantitative characterization of habitat preferences. Lastly, there's been concern that implant tags can have negative impacts on the health of tagged whales, but demonstrating these effects is really difficult. Recent work by Perrotta and Thomas have shown that the early anchor tags affected survival and reproduction, whereas consolidated tags did not. So why revisit all tag data? For one, new methods for location improvement and track regularization via state space models are available. These approaches also mean that we can have more confidence in assessing right whale occurrence in areas of interest from the tag data. Methods for movement behavior analysis have also become available, which can produce key parameters for use in further modeling studies. In particular, the evolution of net square displacement over time has become a useful metric to objectively characterize movement strategies as we see in this schematic, ranging from migration to nomadic, for example. Lastly, methods for characterizing habitat selection and response to environmental variables via step selection functions and species distribution models are now well established. In the example shown here, Thorne et al. Used tag data from pilot whales in the Western North Atlantic to build a species distribution model, which was then used to further assess bycatch risk. By applying these methods on the 7 right whales with high-quality tracks, we obtain a more accurate and spatially resolved characterization of travel speeds, which range from slow, peaking below 2.5 kilometers per hour, to bimodal, to fast, peaking above 4 kilometers per hour. Obviously, there was a lot of spread, but generally those were the trends. High values of move persistence derived from state-space models allow us to characterize portions of tracks as most likely transiting and low values as areas of likely intensified foraging in the dark colors in each of the tracks shown here. Lastly, going back to net square displacement, we observed a diversity of movement strategies ranging from nomadic, as in the red boxes shown there, to home range, essentially animals that remain either near the tag site or that left and came back within the tagging period. And lastly, migrants in the case of the track of Piper from her migration to coastal Florida in 2000. So in conclusion, we can still learn much about right whale movements and migration from mining historical tag data. The metrics we calculated reflected a mix of movement strategies and highlighted individual variability in space use, dispersal, and connectivity. These analytical tools also provide a quantitative foundation for identifying behavioral states and relationships with environmental conditions. And with that, I would like to thank the organizers for the opportunity to present, and thank you all for your attention.